Today we're going to talk about the climate system, and you can see from this satellite imagery of the globe that we have lots of areas with snow and ice, as well as different land cover types. We have deserts, we have rainforests, and we have oceans with different ridges and valleys inside the oceans, and continental shelves, which appear as these light blue areas around. This makes a really complicated climate system. Here we represent that again by showing different pieces of the climate system, the cryosphere, including sea ice, glaciers, ice sheets. The hydrosphere, the water sphere, includes the ocean, rivers, lakes. Glaciers could also be considered part of the hydrosphere, clouds and precipitation as well, including snow. We also have changes in solar inputs affecting the climate system, whether that be from just the general intensity of the sun over time or sunspot activity on the sun. We also have weather processes that take place in the climate system that affect our general climate. We have human influences on climate. When we burn fossil fuels, we give off different gases and aerosols into the atmosphere, and those affect our climate. There's also natural variability with the climate, including volcanic activity, and those volcanoes also give off aerosols and gases into the atmosphere. And here's a picture of our atmosphere from space. You can see here's a hurricane spinning, and we have a very thin atmosphere. In fact, if you use a beach ball as a model for the Earth, the atmosphere would be about as thin as a sheet of paper, so it's quite thin. In fact, most of the action in the atmosphere happens down in this layer where our weather takes place, which is called the troposphere. And in the troposphere, you have temperature decreasing with height. And then we get up to the stratosphere, where temperature increases with height. And then we get up to the mesosphere, where it decreases with height again. And then finally to the thermosphere, where it gets warmer as we go up in the atmosphere. In fact, in the troposphere, this is where most of our weather takes place. This is an image of a cumulonimbus cloud, which sometimes we call an anvil-shaped cloud. And this is a thunderstorm cloud, and we see these all the time in Colorado, especially on the eastern plains. And you can see here that the tropopause, which is the boundary between the troposphere and the stratosphere, is right about on this orange line. And some of the weather got shut up into the stratosphere just a little bit. Those are called overshooting tops, because the updraft from this thunderstorm was just strong enough to do that. But most of our weather sticks right around in the troposphere. In fact, the image of that hurricane that we were looking at, that whole hurricane is just in the bottom layer of the atmosphere, right down in the troposphere. The troposphere extends to about 10 kilometers tall, so that's about 6 miles. If you've ever ran a 10K, you've run the whole distance of the troposphere where our weather takes place. In fact, the tip of Mount Everest is just about at the top of that region, which is why the air is so thin up there. It's very hard to get a good breath of oxygen when you're that high because the density drops off. In the stratosphere, we have our ozone layer. So this shaded area shows you our maximum concentration of ozone in the atmosphere, and that's pretty far up there. And there's a lot of misconceptions involving the ozone layer and climate change, and so I just wanted to point this out and show you that when we talk about the greenhouse effect later and global warming, most of our discussion will take place in the troposphere. And so the ozone layer is actually above where most of this action takes place for our global warming story. So we're not going to include the ozone layer in much of our story for the rest of the class. And here's that image showing density, high density of air molecules at the surface of the atmosphere, and then it starts to decrease as you go up. So you get low density of air molecules higher up. So if you're at a mile high up in Denver and you take a big breath of air, you're going to get a lot less oxygen molecules per breath than you would down in Miami or New York City, which is right at sea level. And if you go to the top of Mount Everest, you'll get very few oxygen molecules per breath, which is why they like to climb the mountain with oxygen tanks to help them breathe.